Good morning, Ananda. Today our topic is mechanical modification. Till our last class, what we understand, what are the various modification methods for improving the ground, for improving the ground as well as soil. What are the various techniques are helpful for improving this ground as per the requirement of the project which we are going to design in that, which we are going to construct for the project, which kind of for the requirement. So based on that, we are having different kind of modifications are in consideration. In that, the main one is whenever we are going to based on the requirement, we are going to choose approximate modification methods. In that, what we observe, the major modifications are mechanical modification, chemical modifications, thermal modifications, and so on. So based on those kind of different methods which we are going to understand in detail about the each and every modification as per the based on the equipment and as per the requirement. In that, the one is mechanical modification. So in this mechanical modification, the main thing which we are going to understand in this, we are using various kind of vibratories, rollers we are using for this mechanical modification of the soil. In this, the density, in this mechanical modification, the density is going to increase by the application of mechanical force, including the compaction of surface layers by vibrators, based on the vibrators. In this, the density, whenever the soil is going to dense, it is made like this, the particles are made like this. In different conditions, they are present in ground. So, because of the construction work which is needed in that location, we are going to dense these soils. So, after these roller movements, vibratories, the density of the soil is going to change. It is going to enhance. It is going to enhance it. So, based on the enhancement of these density, we are going to using these vibrators. We are using vibrators. Those vibrators are also available in different types. So, which is based on the suitability, we are going to choose, we are going to adopt the which type of vibrator is suitable. Based on that, we are going to adopt that particular technique for density increase in the soil for mechanical modification. So, in the different kinds of modification, stationary, dynamic, compact, plate, all are comes under this. They are going to apply the mechanical force to dense the soil. So, for increasing of the soil. In this, the main thing is the compaction. So, already in previous slide we observed. So, like this plus water, we are going to convert like this. So, whenever we are going to compacting, we are going to using the rollers, it means we are going to compact that one. So, all particles are remove this whatever the air and whatever the excess in that is again it is into the like this. So, this based on this compaction, we are going to increase the densified the soil by using the external compactive effect. This external compactive effect may done many ways. It over many ways. So, based on the availability and requirement, both are play a key role for adopting the better technique. In this, one more important property is it is going to increase, that is the stability. Once we are going to densify the soil, it is automatically increasing the stability of the soil. It is going to increase the stability of the soil. So, here based on this, we are going to understand the ground. We are doing the ground improvement for the stability point of view. So here so many different types of properties are all included based on the required properties and existing properties of that particular soil. So based on this, we have to understand in detail in these. So for enhancing or for compaction or for stability, what are the different types of the soil parameter based on the parameters? So based on the required parameters of the infrastructure for physical infrastructure, so for the physical infrastructure which is going to construct or which is going to design in that particular locality, in that particular region, in that soil has different types of property, that ground has different types of properties. So for these properties are existing as per the requirement of the construction work. For requirement we are going to, whether it is may increase or decrease that particular property, it is depends upon the which type of construction. So the existing properties are going to modified for the requirement of the for acceptance for the construction work. So for all these parameters, all these points, we have to keep it in our mind for enhancing the properties for that particular ground. So in that, increasing the stability of the soil is also depends upon the how we are going to compact that whatever the soil is available in that, they are going to densify it. This is the one of the important parameter for increasing the stability of the soil. In this, many types of equipment are also available. So based on the existing soil properties, what are the modifications are required, and in these modifications choose the which type of equipment is suitable for the modification. So by applying the static and dynamic loads of the soil, it depends. Sometimes static rollers are enough for getting the required compaction. Sometimes they may not, because of the depth of the denseness of that soil. It is not enough. The simple rollers, the vibrators may not enough for getting this densifying the soil by using this static loads. In that particular time, we are going to move to the dynamic loads. It depends. So which type of construction is going to choose and what type of construction is going to done by the particular region. So like that we are doing this compaction as a mechanical modification for ground improvement. In this, whatever the things we are going to do in this, coming to the compaction, in two ways we are going to understand in this. The reduction in the volume of the air. So whatever the air particles, how much the soil, water and air we may divide it into like this. So it is going to reduce the air. So because of the the reduction of the air in that soil, so it causes the shear strength. It increases the shear strength, reduce the compressibility, reduce the permeability, reduce the settlement of the foundation, as well as increases the slope stability. So these are the various parameters are going to affect in the compaction of the soil. So based on that, we have to understand in this one. So in this, coming to the one of the parameter shear stress, it is going to increases because of the compaction. We are reducing the air content in the that soil particles, in between the soil particles we are going to reduce the air. The reduction of the volume of the air causes the increases the shear strength, that decreases the compressibility, and also as well as decreases the permeability. It decreases the permeability and the settlement of the foundation. So it depends. The settlement of the foundation is like this. So because of the denseness of the soil, the settlement ratio is more. There is a chance of the foundation are going to settle. It's not good for the construction and it's not good for the structure. So for that is also reduces because of the compaction, and it increases the soil stability. In other way, we represent like this. Whenever the shear strength increases, it's good for the safety point of view as well as the strength point of view. It gives the better understanding. Less compressibility. The less compressibility means it is going based on the various different kinds of loads. Whenever they are going to impose in that, the compressibility already it is its maximum, so it reduces the compressibility. So the effects are very less. Similarly, that permeability also, coming to the settlement of the foundation, it is going to reduce means the whatever the complete construction is in settled state, and this soil stability also increases. So these are the various parameters are going to affect. These are the effects which we observe for the reduction of the volume in air by the compaction. So these are the various parameters which we are going to affect the compaction in the field. Compactive effect, moisture content, soil type, layer thickness, contact pressure, number of rollers passes, speed of rolling. These are all the parameters are going to affect this compaction. How much the compactive effect? So it depends upon the how much load we are going to impose in it, and how much moisture content. Already we talked about the various stages, different types of stages in the soil. So in that is also moisture content also it is going to understand. It is also a factor, that is the one of the important factor affecting the field, and it depends upon the soil type also, and the layer thickness. So it depends. So the simple rollers and the thickness is more. So within the depth, the required depth is more than that. So the layer thickness has also plays a effective role in the compaction. And the contact pressure, how much times of the rollers are going to passes in that particular soil. So one times the effect is different, and the same kind of speed and the same kind of load whenever we are using for the passing of the roller, the effect is different. So it depends upon the how many times. So the number of times and how much the speed of the rolling also plays a role in affecting the compaction factor. These are the various important factors which we are going to understand in the compaction field. So it depends upon the choice of the method actually. So first we have to understand which type choice of the method. It depends upon the client, and it depends upon the demand of the structure. Sometimes if the demand is less, we may compromise on the choice of the method. So it depends upon the demand of the structure, and for which purpose we are going to construct also plays a role for choosing of this method. So the main one in this also, whenever we are choosing this type of soil, and the degree of improvement and require how much cost for the compaction technique, for densifying the soil, the cost and availability of the equipment. So sometimes the cost may less, but the equipment is nearby, it is not available, the time may constraints. So various parameters are affecting the choice of method. So availability of equipment, time, as well as damage to adjacent structures. So some of the equipments, they are going to damage the nearby structures, but they may give better performance even though the nearby structures are not supportive. Means this is also one of the constraints for choosing the better method or appropriate method for identifying this compaction, as well as the durability. So these are all plays a role for choosing the method, and these are all the various factors which are going to affect the compaction. So based on the choice of the method and various types of degrees of the improvement, these are all the parameters which we are going to consider in this our mechanical modification. For choosing the method as well as the affecting point of view, we have to understand, and we are going to take the approximate method based on all these important parameters which we have to consider for that particular construction. And now it is the which type of action. So based on the type of action, rammers, vibrators, rollers. These are the three different compactions which we are going to done in the for the action. So in this, so the maximum occupation is place that is the rammers, vibration and static rollers. Coming to these rammers, the compaction equipment is very light and it's very easy to handle. Coming to these type of rammers compaction, it is light equipment, it is carry by one single person, it is not that much heavy, it is very easy to carry and it very easy to move to from one place to another place. We may check in n number of times. So like that, the equipment is very light and it's very easy to handle. And these rammers are, and coming to these rammers are most suitable for Kojo and semi-Kojo soils. This is not at all for the non-Kojo soils. And this is also the choice of methods. Already we discussed in last slide. So whatever the choice of method we are choosing, so based on this type of the soil, whether it is all aspects, the rammer is suitable, but even though the soil type is not a Kojo, it is non-Kojo soil, means this is not suggested one. So like that, we have to understand the every type of the at the time of the choice we made, we have to take care about the each and every parameter. Then only we have to consider which type or which method is suitable or which method is adoptable for that particular required thing. So like that, we have to understand. So for one of the example, that is rammer. So whenever the remaining parameters based on the type of for coming to the choice of the method in time point of view, in time point of view as well as the required equipment availability point of view, also it is suitable rammer. But coming to the type of the soil, it is not suitable for all the soils. For non-Kojo soils, it is not suitable. Whether the time is acceptable and the equipment availability is acceptable, all other parameters are acceptable, even though the type of the soil is not acceptable, also we have to choose another equipment. So for the affecting the factors of the compaction. So it is these are the dimensions are like this. In these two different types of dimensions, these rammers are available. Frequently the ranges of the blows are going to 500 to 750 per minute. Maximum 250 mm thickness. Here also one more type of coming to the choice of method, layer thickness. Already we discussed the layer thickness as well as the type of soil plays a major role in this choose of this rammer. For Kojo and semi-Kojo as well as the layer thickness is up to 220 mm only acceptable for this rammer equipment, whether it is available, whether it is time is not constrained, even though these two parameters plays a major role for choosing these rammer equipment for the compaction purpose. So the weight of the rammer is about to 30 kg to 1 ton. So it depends which type of the hammer is suitable for the required thing. It depends upon the how the thickness of the max, based on the thickness, whether it is less, so the less weight rammer is adoptable. So like that, we have to understand all these parameters. This is the further rammers. In the also like this we are using. This is the person, and we are using that technique here. The rammer compact surface through impact and vibration. So this rammer is working based on the impact as well as the vibration, the rammers are used at the difficult area where other type of equipment not able to operate. So this is the specialty of the rammers which we are using for the compaction in soil, for the densification of the soil, required densification of the soil. It enhances the compressive strength as well as the reduces the settlement of the foundation. These are the various parameters which we observed in rammers. Coming to the vibrating plate compactors, in these compactors, the weight of the compactor is about 200 kg to 2 tons, and the plate areas between the areas is between 0.16 to 1.6 square centimeter square. So these are the dimensions for vibrating plate compactors. In these vibrating plate compactors, it is used for the small areas. Whenever the requirement is the area is more, the vibrating plate compactors are not at all suitable, and they usually travel about 0.7 kilometers per hour. They are used for small areas like parking slots and etc. Not for huge construction works and everywhere. Whenever the construction is completed, whenever is the compaction is required throughout the area, these kind of vibrating plate compactors are not at all suitable. They are suitable for the parking slots, simple areas, gardening areas, walkways. So these kind of areas, these kind of slots are suitable for compacting vibrating plate compactors, for compacting or densifying the soil. Coming to the rollers. So in these rollers, we have different types of rollers: sheep foot roller, smooth drum roller, pneumatic trail roller, and vibratory rollers. So these different types of rollers we are going to understand. So we will see each and every roller, how they are working and what are for which the choice of method, how the choice of method we are selecting for which type of the roller is suitable for this. All these things we will see in our next class. So these are the some of the web references which is from NPTEL, IIT, and one more mechanical modification, especially for this. These are the two web references. It is helpful for us for better understanding the lecture. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.